Hey guys, this is topic 8 linear equation, and now we're going to learn part 2. So this video, this topic, this section will will assume that you're pretty good with part 1 since we're using a lot of what we learned in part 1 in part 2. So just keep in mind that if you didn't study on part 1, go back in part 1 and then review again, because if you don't, then you'll get confused in part 2 and you're wasting your time watching this video. So let's move on. So in this section, not only we're going to put inequalities to our equation. So what are inequality? It's basically what you guys did before. Like in topic 1, we learned that the symbol greater than, less than, greater than or equal to, and less than or equal to. So if you don't know what the names of the symbols are, it's right here on the parentheses. So let's move on. We know that 5 is greater than 2 since in the number line 5 is to the right of 2. So instead of 5 over 2, what if we replace one of the numbers with a variable? Let's say what is x greater than 2 means. What does x mean? Well, x can be any number as long as it's greater than 2. So it can be 3, it can be 4, it can be 5, it can be 6, etc. etc. It can even be the decimal between the whole numbers. It can be 2.5, 2.9, and then it can even be 2.01, and be 5.1. So all these things are points that satisfy x is greater than 2. So it's so that so we represent it with a line. So the line is basically from around 2 and it goes all the way to your right. But the question is, our $1,000,000 question is, does 2 satisfy x is greater than 2? No, right? Because 2 is 2, so it cannot be greater than 2. So how do we show that? How do we represent the numbers at the decimal that's close to 2 without touching 2? Well, we're going to graph it with an open circle. So that's why it's an open circle. It signifies that up to 2 is not included, but the numbers close to 2 are included to the equation x is greater than 2. How about x is greater than or equal to 2? Well, it's going to look the same as this graph, but the thing that separates this graph with this graph is that 2 actually satisfy the equation x is greater than or equal to 2. So how do we graph it? Well, we're going to graph it with a closed circle. Closed circle means yes, 2 is included. Open circle means 2 is not included. So a shortcut with that is inequality that has an underline, you graph it with a closed circle. Inequality with no underline, you graph it with open circle. So let's have some examples. So before we do some example, how do you graph inequality? Well, first thing first, you draw the number line. And then you're going to identify the starting point. It's usually the number given to you. And then you're going to determine if the graph is open or closed. And then 3 is you're going to pick a number close to the point and then you're going to plug into the equation. So here's the thing, here's how you do it. So first thing first, you draw the number line. And then you're going to figure out if the line is open or closed. Since it's greater than, there's no line underneath, it's going to be an open circle. And now you're going to plug in, you're going to choose a number close to -2, and you're going to plug it into dx. So in this case I chose 0 because it's easy. 0 is greater than or is 0 greater than negative 2. Is 0 negative is 0 greater than negative 2? Yes, that means the arrow points that way. We shade it this way. So that's basically how you do it. So let's have another example. Oh, wrong. We have negative 1 is greater than or equal to x. We're going to identify the starting point. In this case, it's negative 1. Now that we identified that starting point, is the graph going to be open circle or a closed circle? Well, there's an underline here. It's going to be a closed circle. Now, we're going to pick a number close to negative 1 and we're going to plug it in. In this case, I chose 0. You can even pick negative 2 if you want, or 1. Doesn't really matter. In this case, it's 0. So we're going to plug in, instead of x, we put 0 is negative 1 greater than is negative 1 greater than or equal to 0? No. So that means we're not going to shade in this area. We're going to shade the opposite side. So the arrow points the other way. It's never going to touch 0, so it goes to the other way. That's basically it. Pretty simple, right? So let's have another example, our last example. Oh yeah, before we move on, we've talked about the example. Some people, when they graph, whatever the sign points at, that's where they're going to graph it. But as shown as in this example, our second example, the sign points to the right, but the actual side shading is to the left side. So don't just trust the sign. I have students that just shade the area that the sign points and they get it wrong. So the easiest way is just pick a number and then you plug it in. If it's true, shade that area. If it's false, shade the opposite area. So our last example, we have 3 is less than or equal to x. So again, first thing first, identify the point. Is going to be 3. Is 3. Now, is it going to be an open or closed circle? In this case, you should know it's going to be a closed circle already. So now we're going to pick a number. 1. Is 1. Is 3 less than or equal to 1? Nope. So the arrow points to your. So the arrow points instead of to the left, points to the right. It goes to the opposite side. So the best way is just follow my steps. Don't invent new steps, because unless it's super easier than mine, then go for it. But this is like a surefire way for you not to mess up your steps, because it's just 3 simple steps. Now that we're good with graphing, let's try putting in. Now we're going to put in our inequalities to our equation and try solving it. So it's basically, if you know how to solve equation, you basically know how to solve inequalities already. So let's start with something easy. X plus 3 is greater than or equal to 4. So again, we are solving something, so that means we're going to isolate the variable, in this case x. So we want x by itself, so we have to get rid of that plus 3. So how do we get rid of that plus 3? Oh yeah, before we do that, don't forget to draw the line. And then now we're going to subtract 3 on both sides. And 2 plus 3 with minus 3. You're going to be left with x, and then the sign doesn't change. It's still going to be less than or greater than or equal to. And then 4 minus 3 is 1. So x is greater than or equal to 1. Again, it's pretty identical in part 1. So if you know how to do part 1, then you're good with part 2. Most of it. So now let's move on. We have y minus 2 is less than or equal to 5. Our goal is to isolate y, so we have to undo minus 2. How do we undo minus 2? We add 2. And since we add 2 on one side, we add 2 on the other side. Y minus 2 plus 2 is y, and 5 plus 2 is 7. So answer is y is less than or equal to 7. Two more example. So now we have x minus 5 is less than negative 7. Our goal is to isolate x, so we have to get rid of that minus 5. So we add 5 on both sides. Don't forget to draw your line. X minus 5 plus 5 should give you guys x, and negative 7 plus 5 is negative 2. So our answer is x is less than negative 2. So now we're going to solve our last example for addition subtraction. We have n plus 7 is greater than 5. Our goal is to isolate n, so we get rid of the plus 7, so we subtract negative 7 on both. We subtract 7, not negative 7. We subtract 7 on both sides, and you're left with n on your left, and 5 minus 7 is negative 2. So your answer is n is greater than negative 2. Now let us move on to multiplication division. So before we start solving equation, let's have an example. We have 2 times 4 is greater than 4. 2 times 4 is 8, and 8 is greater than 4. This is a true statement. So what if we divide both sides by 2? 2 cancels out, and you're left with 4, and 4 over 2 is 2. And 4 is still greater than 2. So if you divide an inequality, it's still going to be true. Now, how about if we have negative? So we have negative 2 times 2 is greater than negative 8. What is negative 2 times 2? That's negative 4. And negative 4 is greater than negative 8. So this statement is true. So far so good, right? So what if instead of dividing both sides by 2, we divide both sides by negative 2? So we have negative 2 times 2 over negative 2, and negative 8 over negative 2. So if you do this correctly, you're going to get 2 is greater than 4. Is 2 greater than 4? No, this is false. So what do we do? So again, here's the thing. So how can we make 2 greater than 4 true? Well, we have to flip the sign, so that instead of is greater than, is going to be less than. So it's going to be 2 is less than 4. And this is true for when we divide by negative, or we multiply by negative. We have negative 1/3 is less than 8. Negative 1/3 is less than 8. That's basically true, right? So if we multiply both sides by -3, we have this -3 cancels out and you're left with 1 right here. And 8 times -3 is -24. But wait, is 1 less than -24? No. So we also have to flip the sign. So that is going to be 1 is greater than -24. So here's the tricky thing with inequalities and division and negatives. When we divide or multiply both sides of an inequality with negative, we have to flip the sign. We have to flip the inequality sign. We have to flip the inequality sign. So don't forget, when you're dividing or multiplying by negative, flip the sign, because I had students that forget to flip the signs, but they did all the process correct and they're going to get their answers wrong. So be careful on that. So let's have some more examples regarding to this. So we have 2x is equal to, or not 2x is equal to, it's 2x greater than 50. Again, our goal is to isolate x. So we have to divide both sides by 2. And since we're dividing by 2, are we going to flip the sign? Nope, we don't need to flip the sign. So your answer is going to be x is greater than 25. It's still the same sign, same symbol. Now we have negative 5x is less than or equal to 15. Our goal is still to isolate x. Now draw the line. And since we're going to isolate x, we have to get rid of that negative 5. To do so, we have to divide both sides by negative 5. So you're going to be left with x. And then you're going to go 15 divided by negative 3. And negative 5 is negative 3. And since we're dividing by negative 5, we're going to flip the sign. So from this sign to greater than or equal to. Note that this sign has an equal to and this sign has an equal sign underneath. So that sign doesn't changes. The orientation is the only thing that changes. So instead of pointing to the left, it points to the right, or vice versa. The fact that there's a line underneath doesn't change. Okay, you're not going to go from less than or equal to and then just greater than. You cannot go like that. It has to be, it has to have its underline underneath. Okay, so let's move on to some undoing division. Now we have x over negative 7 is less than negative 8, so we want to isolate x, so we have to get rid of that negative 7. To do so, we multiply both sides by negative 7. This side will be left with x, and negative 8 times negative 7 is 56. And since we're multiplying both sides by negative 7, we have to flip the sign to greater than. Now our last example, we have x over 13 is less than or equal to 2. Now our goal is to isolate x, so we get rid of that 13 underneath. To do so, we multiply both sides by 13. 13 times over 13 times x over 13 should give you guys x. And then 2 times 13 is 56. And since we're multiplying by 13, we don't have to flip the sign. It's a positive number. Now, inequalities, as you have known, or in equation, we have multiple operations. And inequalities, you're going to get multiple operations that you need to undo. But if you do it correctly, you're never going to have to flip the sign. most of the time. There are situations where you have to flip the sign, but if you do the steps correctly, you're never going to flip the signs. So let's have an example on that. So we have 5x is less than 2x plus 6. So if you do this correctly, again, I'm just repeating myself, but if you do this correctly, you're never going to flip the sign. What do I mean by that? If you follow the step of eliminating the smaller variable, you're never going to have a negative with your variable. So how does that work? Well, first thing first, we want to eliminate the variable. So smaller variable, in this case 2x. To move 2x to the left side, we have to subtract both by negative 2x. So you're left with 6, and 5 minus 2x is equal to 3x. But what if you move 5x? Well, you're going to get negative 3x, and then you had to get rid of, and later down the line, you had to get rid of that negative 3 because it's on your x, and you're going to do some division on that. So you're going to have to flip the signs. But since we did it properly, we're going to don't have to flip the signs. So now instead we have 3x is less than 6. 3x, now we simply want to get rid of that 3. Divide both sides by 3. 3x divided by 3, and then on this side is 6 over 3. 3x over 3 is x, and 6 over 3 is 2. So if you don't know what steps to do, go back on part 1 and on the last part, and we talk about what steps to do when we have multiple operations and it's pretty long. So now we have x minus 1 times 3 is less than 4 minus x times 2. First thing first, you want to simplify your equation by doing distribution. So you're going to distribute 3 to all the terms inside. You're going to get 3x minus 3. Now we're done with the left side. Let's do some distribution on the right side. Distribute 2 to both 4 and x. You're going to get x minus 2x. Now we want to get rid of the smaller variable, negative 2x or 3x. Which one is the smaller variable? Negative 2x, right? So how do we get rid of that negative 2x? We add 2x. And since we're adding 2x on both sides, don't forget to draw the line. Since we're adding 2x on both sides, we're going to get 5x minus 3 is less than 8. And then we want to get rid of that constant term by adding 3. 5x minus 3 plus 3 is 5x, and 8 plus 3 is 11. 5x is less than 11. Now we have 5x. Now we want to simply get rid of that 5. To do so, we are going to divide both sides by 5, and you're going to be left with x is less than 11 over 5. So here's the steps. So what if you didn't eliminate the smaller variable? What if instead you move 3x? You're going to subtract 3x on both sides, and instead of positive 5x, you're going to have negative 5x on your right side, and later on you're going to flip the sign. But either way you want to go, you're going to be left with the same answer. X is less than 11 over 5. But you're just doing extra steps. So if you did this part properly, you're never going to have to flip the sign most of the time. I just said never most of the time. It depends on the equation, okay? If it allows you, yes, go with the small, eliminating the smaller variable. So what do I mean by most of the time? So there are situations where you can't escape from flipping the inequality, so it's good to know how to when or it's good to know the rule that if you divide by negative in an inequality, you have to flip the sign. Here's an example. Here's an equation that shows that. So in this case, we have 2 minus 8x is less than negative 14. Well, our goal is isolate x. So to do so, we are going to get rid of that 2. How do we get rid of that 2? We're going to subtract 2. And since we're subtracting 2, we also have to subtract 2 on the other side of the equation. So now you're going to be left with negative 8x is less than negative 14 minus 2 is negative 16. You're going to be left with negative 8x is less than negative 16. Now you want to get rid of that negative 8. To do so, you're going to divide both sides by negative 8. Negative 8x over 8 gives you x, and negative 16 over negative 8 gives you positive 2. And since we're dividing by negative 8, we're going to flip the signs from less than to greater than. And that's how you do inequalities in expressions. In an equation. That's how you do it. And that's it for this part. It's pretty short.